Hi everyone, my name is Varela Garcia and this is my video for my 10th project of real analysis. So we'll talk about a theorem that I chose and written and compare it to a AI chatbot written proof and see where I guess it's better to have a human written proof rather than an AI chatbot written proof. So I'll move you guys down to the paper. Okay. Hopefully you guys can see it. And the theorem I decided to prove, so theorem states the following. So we have suppose a function from e to r is continuous and 1 to 1 with e compact, then it must be true that its inverse from f of e to e is continuous. So what does this mean? So we can visually represent this to a graph. Right? Here I chose to graph f of x equals x squared. Right? And then we make, this is the xy plane by the way, then we can get its domain E. So say I restrict it specifically here from 0 to 3. Okay. So since I've restricted it, I have created an interval E, and we can cross the first part where E is compact, because compactness means it is closed and bounded, and because we know it's bounded because it goes from 0 to 3, doesn't go to infinity, which is a good thing, right? So it's bounded, like, it's enclosed, it's inside it, right? And we know it's closed because we decided to include 0 and 3, the boundaries, okay? And yes, we also know that this is continuous because if I decide to take my blue pen and trace this as best as possible, you can see a intersection between the pencil and the pen trace. And I did not lift up my pen, so it's continuous, right? And we know it's 1 to 1 because say I choose f of 9, f of 3, and f of 2, right? So we do this for 1. Okay. It says that if these two are the same, then so if f of 3 equals f of 2, then 3 must equals to 2, which is not true, right? So this just means that when you choose a number here, you get a number here, and it's not the same as all the other numbers. Okay? So here I kind of visually filled it out, so that should be a 4 and this should be a 1. Okay. So what does it mean by f inverse being continuous? So we go down here, we move the dice down as well. We have a graph, and the inverse of x squared should be the square root of x, right? And f of e is this part of the graph, right? So from here to here, this should be 9 and there should be 0. Right? It just means that, again, I could trace this out without lifting my pencil, but instead of going from 0 to 3, I'll start from 0 to 9 and then plot something on the x-axis. So instead of going from x to y, I'll go from y to x. Okay. So that's the visual representation, and now we can start with the proof. Okay. So I'm going to use this pencil. So So it is generally a good idea to write down what you already know from the question, right? So I just kind of copy and pasted the conditions. Okay. And now we can start writing down the definitions or any theorems we have. So I will start writing the definitions. Then E must be closed and bounded. E is compact. So we know that E must be closed and bounded since E is compact, which we kind of showed up here, right? What else? So we can define an inverse of f of v to E because one, we know it's f of v because, like I said before, if this is closed, then that must be closed, and we know the values here. And we know an inverse exists because our function f is 1-to-1. So for an inverse to exist, a function must be 1-to-1 and onto. Right? So we got those conditions. So we know this exists. We can define that. So okay, now write down the definition of continuity. Okay, so this is the definition where I just kind of plug it in, where epsilon and delta are just other variables, Greek variables, right? They both have to be greater than 0. Then we know we could pick up two numbers from this guy. We go plug two numbers, x and x naught, to have that those numbers subtracted is less than that delta, right? Delta has to be greater than 0, and that implies or suggests that the inverse of those two must be less than epsilon. Okay. So now observe that when you do the inverse of function, that or the function of an inverse of that same function is x, right? We can see that, for example, if I take the step forward, right, let me visually show you guys. So if I take a step forward, I can reverse what I did or cancel what I did by taking a step backwards, right? Now if I decide to take a step backwards, I could cancel that by taking a step forward, right? So I'll be in the same place. So likewise with functions, we can observe this. And we can observe this. Then we can take the function of the inverses to kind of cancel them out. Take this, and we get epsilon. So we can see epsilon equals delta. Then f inverse is continuous. And now we have proven it. We do draw a little square, right? And the proof of this is done. So now let's pan to the AI generated proof and talk more about over there. Okay, so this is the AI proof, or my document to the AI proof. Let me make this bigger. So this is the proof I did on hand, which was earlier in the video. And this is a summary, which I won't go over. And this is the AI proof. Okay. So the prompt I gave it was, can you prove the following theorem, right? And we just state the theorem. And here is a screenshot of it, right? So here's the proof. F is 1-to-1, and this defines E and F of E, and F inverse exists, and I guess you guys You guys can kind of read this. Pause the video. Feel free to pause the video to read this. Let's go down. This should be the result of that, right? And now we compare. If you guys take the time to compare it to my proof that I have written and this, you guys can see that this AI proof is shorter, definitely shorter, because it took out the repetition that we had in the beginning, and it cut off any it just cut off the repetition we had in the beginning, and it goes straight into solving it. Right? This is good for a beginner who wants to get into proving math, but it is bad as well, since AI sometimes tends to jump between steps. So, for example, in here we have, I can highlight, I believe. We have here, right, and the real numbers, this fancy R, is compact set. Every compact set is closed, right? So we have this, which is what I had before, and then it jumps that therefore the pre-image or E is closed and F of E, right? So it doesn't exactly tell us why or how it gets there. It just kind of jumps there. So that's where kind of the trust on AI proofs kind of goes bad, because it will assume you know what to do, you know some view analysis, when that might not be the case, right? Yeah, this is the end of my video. I've gone a bit too long. Hopefully you guys enjoyed that. I will do some edits to this, and yeah, thank you for hearing me talk about proofs and doing a bunch of proofs, and hope to see you then.